All right, I think we are recording. So, today we talked about 2.1, 2.2, solving linear equations. We have discussed inverse operations. We've talked about how to solve one-step equations, how to solve two-step equations, and that brings us to the back of this page, which is solving when you have variables on both sides, and how to solve multi-step equations. Let's begin with variables on both sides. If I take a look at this example here, I'm going to solve this equation by drawing the line down the middle. Now, I might look at this piece and say, oh, I know what to do. I need to add 2 and then divide by 5. The problem is that I'll have an x on the right and an x on the left. So what we actually need to do is we need to get x on the same side, which means I'm either going to minus 18x from both sides, or I'm going to minus 5x from both sides. I tend to go after the smaller term, so I'm going to subtract 5x from both sides. What happens then is my x's cancel, leaving me with, on the left, I have 13x equals, on the right, I only have this negative 2. 13 times x equals negative 2. I divide by 13. My 13s cancel. Is there anything I can do to negative 2/13? No, I can't. I cannot reduce it. I can't even turn it into a mixed number. So this is my answer. X equals negative 2/13. That's pretty much all we can do there. So let's summarize our process. What exactly did we do? Well, when you have a variable on the left side and the right side, you need to get rid of one of them. It doesn't matter which one. And you are going to either add or subtract whatever that term is on both sides to make it go away. So, when you have a variable on both, when you have variables on both sides, you are going to eliminate the variable. So you're going to eliminate one of the variables either on the left or the right, doesn't matter, using addition or subtraction. If we take a look at this u-try, I have negative 3x on the left. I have positive 30x on the right. I got to make one of those go away. I will either add 3x so that this cancels, or I will minus 30x so that these cancel. Again, it makes absolutely no difference which one you choose. You will land on the correct answer as long as the rest of your process is correct. So I'm going to erase that. Let you work out the u-try. I'm going to check this tomorrow. And let's go on to the next thing. Solving multi-step. There's supposed to be an E here. If you can add that in, that would be fantastic. Solving multi-step equations. That's what we're working with. Multi-step equations. There's 3 basic steps here. First thing you need to do is simplify the left-hand side and the right-hand side completely. Okay. Step 1, simplify each side of the equal sign. Step 2 is to get x on the same side. Using either addition or subtraction. And then step 3 is to solve using your backwards PEMDAS order. Can you get rid of anything using addition or subtraction? Can you get rid of anything using multiplication or division? 3 basic steps. Simplify each side of the equal sign, get x on the same side using addition or subtraction, and then solve that thing. You should be at a 2-step equation by the time you get here. So let's do an example. And I'm going to start this off the way I start every equation, by drawing the line. I look at each side and I ask myself, is there any way I can make this simpler? Well, if I look at the right-hand side, can I simplify that? No. I look at the left-hand side. Can I simplify that? Absolutely. What I need to do here is I need to take this -2 and distribute it. I get 8x minus 2x plus 2 equals 7x. Remember, you're taking this -2 and you're distributing it to both terms. Be sure to include that sign. Now I look at the left-hand side and I say, well, is there any way I can make that simpler? And I totally can. I can combine like terms. So I distributed, I combined like terms. Well, I'm going to combine like terms. My like terms are positive 8x and negative 2x. Those combine to make a 6x. Now I look at this and I say, okay, on the left-hand side, is there anything I can do to simplify that? And the answer is no. But I do notice that I have x's on the left and I have x's on the right. That's a problem. I like to eliminate the smaller of the two terms. So I'm going to minus 6x from both sides. What happens is my 6x's are going to cancel, leaving me with just 2 on the left-hand side. 7x minus 6x is 1x. And I don't have to write the 1 there. My final answer here is just x. X equals 2. And how can we check our work? We can plug that 2 back in. Okay. For the you try, again, I'm going to have you do this one. It's going to be the same idea. You're going to distribute. Well, actually, you're going to draw the line. That's what you're going to do. You're going to draw the line. You're going to distribute the 3 to both terms. You're going to combine like terms. You actually don't have an x on both sides, so you don't even have to worry about that step. And then you're going to solve. Let's go back to this one. We distributed, we combined like terms. We get x on the same side. And we solve if we can. In this case, we only had the 1 there. We didn't have anything else we had to do. So that's not so bad. Let's go down. Types of solutions. There are actually 3 different types of solutions that you can get here. You can have one solution. One solution is the most common case. If you're going to get one solution, you're going to end up with something like x equals 2. Right? This is a pretty standard case. X equals 2 or x equals 5 or x equals -1/2. Something like that. You will get an answer for x. The second one is no solution. For no solution, what's going to happen is as you're working this out, all of your variables will disappear and you'll land on a false statement. A false statement might be something like 2 equals 5 or 0 equals -12. something along those lines. Well, what this means is that you have no solution I often abbreviate solution as SOL''N. I believe on MathXL you also have this. This means the empty set. That means there is no answer that will work. The third case is infinitely many solutions. And basically what that means is you could plug any number you want into that equation for x. You will land on a true statement every single time. Every number will work no matter what. So the same situation will happen. All your variables will cancel, except this time you'll have a true statement. A true statement might look like 2 equals 2, or 0 equals 0, or -7 equals -7. This is true. And what it means is that all real numbers will work for an answer, and so you can write all real numbers, which we abbreviate like that. We talked about this symbol in the last chapter. So I'm going to do an example. Let's go to this one here. I start by drawing a line down the equal sign. I look at the left-hand side and I notice there's a bunch of stuff I can do to simplify that. I distribute the 2. I get 2x plus 12 minus 2x equals 12. So I distributed. Now I'm going to combine like terms. My like terms are positive 2x and negative 2x. Positive 2x and negative 2x actually cancel each other out, don't they? They equal 0. So since these guys cancel, what I'm left with on the left is 12, and what I have on the right is 12. Is that true or false? Well, that's true. 12 is the same as 12. And what this tells me is that any number I plugged into this equation will give me a true statement, so we say all real numbers. All right. You have 2 more problems to do. You have this one here, and you have this one here. So all in all, you have 4 problems on the back that I want you to solve before coming to class. I will be checking for these. They are this first you try, this second you try, this third you try, and this fourth you try. I will be looking for these to be complete in order to get full credit for this video. Thank you so much. Have a wonderful day, and I'll see you tomorrow.